Today we'll start a new chapter, electricity. So in this chapter we will be learning about the concept of current. Then we will see what is potential difference, voltage, resistance, how the resistance can be connected in different ways. Then we'll see certain rules or Ohm's law. Then also we will see some household circuits and all. So we will start with the chapter electricity. The first concept in this chapter is electric current. So let us see what is a current and what is an electric current. So when you hear the word current, we often heard about wind current, then we have heard of water current, etc. So when you see all these currents, we find that there is a movement. Okay, so if it is a water current, there is a movement of water current. If it is a wind, there is a movement of wind. Okay, so current actually means something which is flowing. Now let us see what is electric current. Okay, so electric current, generally speaking, it is actually the flow of charges. You know, there are positive charges and there are negative charges, or electrons are there, positive charges are there. So if these charges, positive or negative charges, if they are flowing or if they are moving, we can say that an electric current is being produced. So flowing of charge constitute an electric current. And in smaller classes you have learned about these positive and negative charges and all, electrons you have learned. Now also you know that in metals, let us suppose you have a piece of metal. You know that metal, inside the metals, the one which is flowing, or the conduction, is mainly due to the flow of what? Electrons or negative charges. These electrons, when they are flowing, will constitute a current which is known as electric current. And also maybe you have come across the case of electrolytes. When we are doing electrolysis, you must have come across the word electrolytes. So in electrolyte also the current will be conducted, and in electrolyte the particles or the charge which is carrying the electric current is ions. Positive ions are there, negative ions are there. So either the positive charge movement or negative charge movement will constitute what? Electric current. So we can say that electric current is the flow of charge. Now speaking about the electric current in terms of equation, let us see how can you define electric current in equation form. Okay, so I told that if charge is moving, so let us consider that Q is a charge which is moving. Q is the amount of charge which is moving through a conductor. Conductor means through which the electricity or electric current can flow. So let us suppose that Q is the amount of charge which is flowing through a conductor, and also let us suppose that T is the time through which the current is, the charge is flowing. Okay, so an amount of charge Q is flowing through a conductor in a time T seconds. So if such is a situation, then we can say that the electric current is represented using the letter capital I, is equal to charge upon T. Or you can say that electric current is the rate of flow of charge. So you know that rate means it is actually the speed. So how many charges are passing through a conductor in a particular time, we name that to be the current. So we can define electric current as the rate of flow of charge through a conductor. Okay, so rate actually means in a particular time how much charge is being flowing through a conductor. So this equation is important. current is equal to charge upon time. Now let us see the unit of current. Unit of current. So I told you that current is equal to charge divided by time, or charge upon time. You know that the charge is having an unit coulomb. Sorry. And time, as you know, the SI unit is second. So what will be the unit of current? Current will be having unit coulomb by second, and this coulomb is represented using capital C, and second, as you know, it is represented using small letter s. So you can write the unit of current as coulomb per second, or coulomb second raised to minus 1. And this coulomb second raised to minus 1 is given another name, and that is known as ampere. Ampere, and it is represented using capital letter A. Okay, so unit SI unit of current is ampere, which is represented using the capital letter A, and 1 ampere is equal to 1 coulomb by 1 second. Okay, so let us define 1 ampere. Suppose you are asked to write what is 1 ampere, or what is how will you define 1 ampere? How will you define it? So if 1 coulomb of charge is moving through a conductor in 1 second, we can say that a current of 1 ampere is flowing through that conductor. Did you get? So if 1 coulomb of charge, if any charge which is having 1 coulomb value is traveling through a conductor in 1 second. Okay, so within 1 second, if 1 coulomb is traveling through a particular section of conductor, then we can say that 1 ampere of current is flowing through that conductor. Okay, so that is the definition of 1 ampere current. Okay, now in addition to this ampere, we have smaller units and higher units of ampere. That is, we can have milliampere. So 1 milliampere. Milliampere is a smaller unit. So 1 milliampere will be, milli means 10 raised to minus 3. So 1 milliampere will be 10 raised to minus 3 ampere. Then again, still more smaller units are there. Microampere. Microampere. So micro means 10 raised to minus 6. So microampere is 10 raised to minus 6 ampere. So these are smaller units of current. Okay. Now let us see the definition once more. So current is defined as the rate of flow of charge, or you can say it in another words, current flowing through a conductor is the amount of charge flowing per second through it. So that is the introduction about the current. Now I told you that there are positive charges and negative charges. So when you think about negative charge, the first member or first thing which you have in your mind will be the electron. Okay, so electrons are having negative charges. And in smaller classes you have learned that these electrons, one electron, that is will have a charge, that is, if we have one electron, the charge on that electron will be 1.6 into 10 raised to minus 19 coulomb. Okay, and there is a negative sign here to show that the charge of electron is negative. Okay, so one electron will be having what? 1.6 into 10 raised to minus 19 coulomb. So actually from this we can define 1 coulomb. One electron is having this much amount of coulomb. So what will be 1 coulomb? So you can easily, using mathematics, you can easily find out what is 1 coulomb. 1 coulomb will be the charge on how many electrons? 1 upon 1.6 into 10 raised to minus 19 electrons. Charge on 1 by 1.6 into 10 raised to minus 19 electrons will give the value of 1 coulomb. So if you calculate that, you will see that the value of 1 coulomb will be equal to what? The charge on, if you divide and see, you will get the answer to be 6.25 multiplied with 10 raised to 18 electrons. Okay, so if you have 6.25 into 10 raised to 18 electrons, then we have 1 coulomb of charge there. So you should imagine how many number of electrons are constituting a small charge 1 coulomb. You need 6.25 into 10 raised to 18. That means 625 into 10 raised to 16. So you have to put so much of zeros there. So that much number of electrons are actually constituting what? 1 coulomb of charge. Okay, or you can say that only if this much amount of electrons, so many number of electrons are there, are passing through what? A conductor, then 1 coulomb of charge will be passing. So if so much of number of electrons are passing through a conductor, then how much charge will be there? 1 coulomb of charge will be there. Okay, now let us take the case of ampere now. So if a conductor have 1 ampere, suppose I am saying that a conductor is having 1 ampere of current. What does that mean? Actually, in that particular conductor, 6.25 into 10 raised to 18 electrons are moving in 1 second. Okay, you know that ampere, 1 ampere is what? 1 coulomb by 1 second. That means 1 coulomb of charge should travel in 1 second. So we found that 1 coulomb of charge is what? Is the charge possessed by 6.25 into 10 raised to 18 electrons. So if we say that 1 ampere of current is flowing through a conductor, it means that in that conductor we can assume that there are 6.25 into 10 raised to 18 electrons that are moving in 1 second. Okay, so did you understand? 1 ampere flowing through a conductor or a metal, actually metal, because electrons are moving inside the metal, or the conduction of a metal is due to the flow of electron. So in a metal, in a metallic conductor, if I say that 1 ampere of current is there, it means that 6.25 into 10 raised to 18 electrons are moving in that conductor in 1 second. So you should imagine how many electrons will be flowing in each second in metallic conductors. Okay, so now that is the case of any conductors. You know that any charge, that is we consider charge using, or we denote charge using the letter Q. So any charge Q, we can represent them in terms of electron, that is we can represent them in terms of electronic charge. So electronic charge, you know, it is 1.6 into 10 raised to minus 19 coulomb. So it can be seen, or we can represent any charge in terms of electronic charge. Okay, so let us consider that we have, so we don't know, in a conductor, let us suppose that we have n number of electrons. Okay, so the value of n can be 1, 2, 3, 4, 1000, millions, any. Okay, so let us consider that n number of electrons are there in a conductor. So we can easily calculate. So if n number of electrons are there in a conductor, then total charge in that conductor, total charge is represented by Q. What will be the total charge? That will be n multiplied with E, where E is what? E is 1.6 into 10, charge of 1 electron is 1.6 into 10 raised to minus 19 coulomb. Okay, so if n number of electrons are there, then total number of electrons in that particular conductor, or total charge of that conductor, will be n into E, or n multiplied with E. So it is easy to find the current there. What will be the value of current? Current is total charge upon time. So here total charge is what? Ne upon T. So if you know the number of electrons in a conductor, you can easily find the current flowing through that conductor using this equation, that is N multiplied with E by T, where N will give the number of electrons, E is the charge of electron, and T is the time of flow of electron. Okay, so that is about the introductory portion of current electricity. Now in next sessions we will see what is potential difference, what is the use of cell, then we will also see how the resistance happens, what is resistance, what are the factors affecting resistance, potential difference and all. Okay, so that all we'll see in the next session.